Vectors. Vectors. In physics, vectors are quantities that quantities that have both magnitude and direction. Magnitude and direction. So, but in mathematics, we represent vectors as two-dimensional planes having x and y. If we are putting it this way, in column, it's called a column vector. Here, the x represents the x direction, and y represents the y direction. That's the vertical direction for y, and x the horizontal direction for x. Now, we can also put it on a graph so we understand. We have, for instance, say we have 2, 3, meaning 2 to the right and 3 up. Come with me. Now, this is what I mean. Horizontal, this is the x coordinate. That's horizontal. And up here, the vertical, y coordinate. Let me take it this way, okay? Let me make it here, y. So we can see. We have 2 and 3. Let's see. We want to get a point A, which is 2, 3. This is A. A is equals to 2, 3, or 2 and 3. 2 to the, let's start from the origin here. 2 to the right, 1, 2 to the right, and 3 up. 1, 2, 3. So our point A is there. Our point A is there. 2 to the right and 3 up. If our origin is O, the vector is at A, meaning from O to A. O to A, the direction. This is what we mean. This is what we mean. Okay? We will not be representing it much on the graph now. We'll be doing it on a plain board so we can get the insight of vectors. Okay, let's continue. If a vector is drawn this way, say from a point A to a point B, the direction going like this, meaning from A to B. Look at the direction. A to B is giving this as A, B, represented this way. Saying is going from A to B, just as you're seeing the line. Okay, if it goes from B to A opposite, it means that B to A, like this, is the negative of anything A to B represents. Say A to B is A. Let's say A to B is small letter A. B to A will be negative letter A, saying it is going to the reverse direction. It's going to the reverse direction. Let's have this at the back of our minds. We go over to another aspect. Now we're going to addition and subtraction of vectors. Addition and subtraction of vectors. Now, let's write down some vectors. Say A is a vector. We're going to put down the column vector 3, 4. B is another vector, -2 and 1. C is also another vector, -4 and -3. Okay, now we want to look at how to add and subtract vectors. Let's see, take the first example. Let's take an example here. It's okay, question one, add the following vectors. Okay, let's just do the following. Say A plus B. 2, let's see, B plus A. B plus A. I think, let's see these first ones. A plus B. A plus B will give you, A is 3, 4 plus B -2 and 1. So you have 3 plus -2, that is 3 minus 2 is 1. 4 plus 1 is 5. And you have it. So easy. So easy. Let's see the second one. B is -2, 1 plus, this is 3 and 4. So we have a vector like this. -2 plus 3 is 1. And 1 plus 4 is 5. Wow. The same, it shows a property, a commutative property. A commutative property. Let's go to subtraction. Let's look at examples regarding subtraction. Now for subtraction, we have that C minus A. C minus A. Now look at C, -4, -3, minus A, 3 and 4. So we have -4 minus 3 is -7. -3 minus 4 is -7. We've done that of the first part. If it's too fast, kindly reduce the speed so you can understand. Let's go to the next one, B minus C. B minus B is -2 and 1 minus -4, -3. So you have -2 minus -4, which is -2 plus 4, which is 2. 1 minus -3, which is 1 plus 3, you have 4. So that is the answer. Misconceptions students may have will be those students struggling with directed numbers. You may have a little time understanding the concept, but it's simple. Now let's look at this. Multiplying a vector by a scalar. What is a scalar? A scalar is just size, magnitude, like we know it in physics. A scalar quantity is any quantity that has only magnitude but does not have a direction. In this case, we just take it as a constant, a single number, a constant. Say if you have A to be A is equal to 1, 2. This is the vector. And you are asked to find 2A. This will give 2, 1, 2, which will be 2 times 1, 2, 2 times 2, 4. Tara, we have it. Just straight multiplication. Straight multiplication. That's how we multiply a vector by a scalar. Straight multiplication. Now we're going to another aspect. I think we're going a little higher. We're moving a little higher to getting magnitude of vectors. Magnitude of vectors. Now the magnitude of a vector is simply looking at how to quantify a single vector by its size, by just its size. The length of line can be denoted as its magnitude. If you have a vector, say A, B, like this, to be 2, 3, the magnitude is normally written this way. To get, this is how it's written. They only want the size. And you can do this using Pythagoras theorem. Now, let's see how it's gotten. Let me make this 4. Let me make this 4. How is it gotten? It means that if you have your graph like this, sorry, I'm going to use the plain board. I'm going to use the plain board. Saying that this vector moved 4 to the left, 4 to the right, and 3 up. Okay, this means our vector moved 4 to the right, 4 to the right, and 3 up, 3 upwards. So this is where it is. It will be here. From this point, say from this point, it moved to this point. Say from A, this is A, to B. This is the direction. Now, if we were asked to get the magnitude of this vector, meaning they want to get the length of line AB. The length of line AB from A to B. We want to get the length. To get the length, let's make this O. It becomes, using Pythagoras theorem, this is the hypotenuse because this is a 90 degree. The horizontal meets the vertical at 90 degree. So this will give us AB all square, which is equal to AO all square plus OB all square. Okay, all square. So this is magnitude AB square. AO is 4 square. OB is 3 square. So the magnitude AB square, 16 plus 9. 4 square is 16. 3 square is 9. So you have AB square equals to 25. Okay, I guess I'm not too fast. So we now have, let me do here, AB is equal to the square root of 25. So magnitude AB is equal to 5. Magnitude AB is equal to 5. This is how you get magnitude of a vector. Okay. Now let's quickly look at position vector. Position vector. Position vector is simply talking about locating a vector from a reference. Our reference is O at origin. So if we want to locate this from O, we can say it is OA from O to A. Let's go. The position vector of this is the position of A from O, which is 2 to the right, 2 to the right, and 1, 2, 3, 3 up. This is the position vector of A. Position vector, like I said, is locating a vector from a reference. And a reference with this example is O. That is about position vector. When we go to the next stage, we will look at the significance of this position vector to help us understand it. All these we're building up knowledge for the main deal, which is vector geometry. Vector geometry. Vectors are not fixed. Any vector having both magnitude and direction anywhere can be represented as same. They are the same as long as they have the same magnitude and direction. So in vector geometry, we want to define a path, or want to define shapes using the idea of vector, knowing a line can be located with magnitude and direction. That's x and y. X and y. A line can be represented using x and y coordinate to locate points. So let's see. If you have these points or a line like this, 1 to this point, this line and this. If this is O, here is A, and here is B. Let's assume that from O to A is small letter x. O to B is small letter y. Then A to B, we do not know, not given. We can actually represent length AB in terms of x and y. Note, any line that is of the same length as OA must be represented as x. We're not saying OA is just fixed here. No. In vector geometry, any line having this length is represented as x. And any line having this length is represented as what? Y. That's what we mean. Even if we see the same length somewhere else, we know we'll represent it as what? X or Y, as the case may be. Now, there's this rule I want us to use here. The rule is this. We are going to look at clockwise direction. Clockwise direction must be equal to anti-clockwise direction for this vector to be same. For it to be same. Let's see. Clockwise. O to A is clockwise. Look at this. Clockwise. Clockwise. And clockwise. Let me go this way. Clockwise. See, we're moving in a clockwise direction. Any line that is against our direction will be put in the anti-clockwise part. Any line that moves with our direction will be placed in the clockwise direction part. That's the left hand part. So let's see. Here is saying O to A is moving in the clockwise direction. So we put it at the left hand side. OA. AB moving clockwise, we add it. AB, sorry. AB clockwise. OB, no, there's no OB, but there's BO. It is moving anti-clockwise, so let's put it OB in the anti-clockwise direction. So we have defined this triangle. We have defined the triangle. So we can say, let me come here, put it here. OA is X. AB we do not know. And OB is Y. So AB can be said to be Y minus X. Answer. Now we've represented it. We have represented it. Remember, OA is X, OB is Y. So we have represented line AB in terms of X and Y. Let's look at this example. You have OA as -1 and 2. You have OB to be 3 and 4. Now, the question now says find the magnitude of AB. Or find the magnitude AB. Let me put it that way. Sorry. Find the magnitude AB. Find the magnitude AB. Find the magnitude AB. Sorry. Find the magnitude AB. Look at, we're to find the magnitude of AB. Just as we've said, following that rule, the clockwise and anti-clockwise. Let's see. Clockwise equal to anti-clockwise. Look at, go this way from our reference. Clockwise, clockwise, clockwise. So clockwise OA is clockwise, OA clockwise, AB is clockwise, AB is clockwise, BO is clockwise. No, but this goes to the opposite. Okay, let me put the arrows there so we'll not be confused. Goes from origin, these are origin, but this is anti-clockwise because it's going opposite to clockwise direction. This is OB is the anti-clockwise. So we have it to get AB first. We have OB minus OA. So AB equals to OB 3, 4 minus OA -1 and 2. So AB will give 3 minus -1, that's 3 plus 1, which is 4. 4 minus 2, which is 2. We have gotten the value. The next is for us to find the magnitude. For us to find the magnitude will be AB. The magnitude of AB is root 4 square plus 2 square. That will give us root 20. Root 20. Root 20. So AB is your calculator. You have to be 4.5 units. Okay. 16 plus 4, 20. So that is for that. Now let's look at this question. This is the part, A part of the question is an IGCSE question. It says, that's the triangle there. It says BC, line BC is represented with, BC is represented with A, and AC represented as B. They say find AB in terms of small letter A and small letter B. So let's look at part A of the question. Let's solve it because of our board. We're going to write the second question down. Now, AB. Using our rule, clockwise and anti-clockwise. To help us, clockwise equal to anti-clockwise. Show that is in equilibrium. In equilibrium. So for the clockwise, we have, let's start with A. From A to C is clockwise. A to C is clockwise. AC clockwise. C to B is anti-clockwise. That's BC, sorry, BC. C, it should be C to B, but look at the arrow is pointing B to C, so it's anti-clockwise. B to C. Please pay attention to the direction of the arrow, or AC, A to C, BC, B to C. Okay, now they say we should find the value of AB. A to B. A to B, if you look at it closely, is anti-clockwise. So A to C is anti-clockwise. I want us to look at it very well. That's anti-clockwise. Let me make it even. Okay. Anti-clockwise. So we have this. Good. Good. So A to B is anti-clockwise. Okay, so we have this. So this AC is represented as B equal to BC represented as A, AC, sorry, AB, I mean, AB, sorry, AB, I mean, so AB, we do not have what it represents. So we can just rearrange it. This is AB will give us, if you change it, will be B minus C. Sorry, B minus A. B minus A. So we've gotten the answer to the first part of the question. Now I'll clean this and write what the second part of the question is. So we have the B part of the question. Still that same question, the B part. M is the midpoint of BC. X divides AB in the ratio 1:4. Find XM in terms of A and B. Let's join X to M. XM from X to M. Let's see what we have. Something like this. Something like this. from x to m. Now, let's see. We'll have a triangle like this. Let's look at where we'll have the triangle. We'll have a triangle, like this. I hope you guys are seeing the board. A triangle like this. Just present it out. Present it this way. This is M. This is X. This is B. Good. We've drawn it out. Now, the next thing, let's represent them. We know that M is the midpoint. So if BC is M, BM will be, if BC is A, this is what represent from here. BC is A, so BM will be half of it because midpoint. M is the midpoint, BM is midpoint. BM is half A over 2. Or let me just put it this way so you won't get confused. 1 over 2 of A. And we know AB is B minus A, what we've gotten. But they say X divides AB in the ratio 1:4. It means that if you split AB into 5, one part is AX and the remaining 4 parts is XB. So 4 out of 5 is XB, and XB 4 out of 5 is A of AB is XB, which is B 4 over 5 B minus A. Look at it. 4 out of 5. What that means, X divides AB in the ratio 1:4. It means that if you divide AB into 5 parts, AX will take 1 part, while XB takes 4 parts. Altogether is 5. So we want to get the value of XM. We know XB to be that, XM this way. Now, let's apply the rule we said, the clockwise and anti-clockwise rule. I think I'll put it here because of our space. Clockwise equal to anti-clockwise. For clockwise now is XM. XM is clockwise, going this way. MB should be MB, but it's opposite, BM, so it's anti-clockwise. BM is anti-clockwise, and we should go this way. BX, no, we have XB, anti-clockwise, so XB, anti-clockwise. This we have as XM will be BM is 1/2A plus XB is 4/5 bracket B minus A. Now let's bring them together. So if you look at this, XM gives A/2 plus 4B/5 minus 4A/5. What did I do? I only opened the bracket. I opened the bracket. Next we have, let's collect like terms. This is XM, gives us A/2 minus 4A/5 plus 4b over 5. Let's see. Let's adjust it. This will give us the LCM of this. Let's see the LCM. This is 10. 2 into 10 is 5. 5 times a, 5a. 5 into 10 is 2. 2 times 4a, 8a. Plus 4b over 5. This gives us minus 3a over 10 plus 4b over 5. So we will just arrange it properly. So xm, our xm will be 4b over 5 because we cannot put the negative in front, minus 3a over 10. This is the answer. We've represented it, so that is the answer.